Hello everyone, this is Ketish here. In this video, I'm going to go through the AQA Combined Science Chemistry Paper 1 Foundation Tier from 2023. In this video, I'll be going through questions 1 to 5. This paper is 1 hour 15 minutes long. And it's out of 70 marks. Questions 6 and 7 appear in the higher paper as questions 1 and 2. So I'll go through them separately and attach them as separate videos as a playlist at the end of the video. So let's have a look at question number 1, which is on the topic of atomic structure and the periodic table. All substances are made from atoms. Figure 1 represents a beryllium atom. What is the number of protons and number of neutrons in the beryllium atom? So number of protons, right, before I do that, let me label this quickly. So the positive charge is the protons. The dark circle is the neutrons. So how many protons are there? There's 4 of them. And neutrons, there's 5 of them. Together, protons and the neutrons form the nucleus. That's the electrons on the outside in shells. And there is 4 of them as well. That's the energy level or shells. So protons is 4, electrons is 5. Figure 2 represents a beryllium ion. What is the relative charge of a beryllium ion? Well, it has lost both the electrons in the second shell, so it should have a +2 charge. Figure 3 shows the arrangement of atoms in the 3 states of matter. So A is a solid. This will be a liquid. And this is a gas. Which state of matter is represented by state C in figure 3? Okay. Which state of matter is represented by state C? Okay. State C is a gas. What is the name of the process when state B changes into state A? So that's a liquid changing into a solid. Let's label that as well. So if A goes to B, a solid becoming a liquid, that's melting. The reverse is freezing. Liquid to gas, that's evaporating or evaporation. And the reverse is condensation. So B to A will be freezing. How can state B be changed into state C? So state B was a liquid, remember, state C is a gas. How can you change a liquid to a gas? By heating it. By heating. You could say boiling as well, or boil the liquid. Experimental evidence led to the scientific model of the atom changing over time. Figure 4 shows 3 models of the atom. So you have the nuclear model, plum pudding model, and the tiny sphere model. So this was the first model that was proposed, second model, and this is your third model, the nuclear model. So what is the order of the development? So that would be number 3. And the existence of neutrons was discovered by James Chadwick, right? Bohr is responsible for saying that electrons are in shells. Mendeleev has nothing to do with the atomic structure, it's to do with the periodic table. He proposed the modern periodic table. Let's have a look at question number 2, which is on chemical changes. A student investigated the temperature change when magnesium was added to zinc sulfate solution. Figure 5 shows the apparatus. So you have 50 centimeter cube of zinc sulfate solution in a beaker with magnesium and a thermometer, which is labeled as X. What piece of equipment is labeled X? That is a thermometer. Which piece of equipment is the best to measure, used to measure volumes of solution? That would be a measuring cylinder. The student added 1 gram of magnesium to 50 centimeter cube of zinc sulfate solution and measured the temperature increase. Student repeated the experiment 2 more times. So you've got results in the table: 7.6, 7.3, 7.6. Calculate the mean. So we can calculate the mean by adding those 3 values up. There's no errors because they are all similar results. 6. Add them up and divide it by 3, and that would give you 7.5. 7.5. The student then added 1.2 grams of magnesium to 50 centimeter cube of zinc sulfate solution. The temperature increased by 9 degrees Celsius. Okay, 1.2 grams to 50 centimeter cube. Temperature increased by 9 degrees. Calculate the temperature increase when the student adds 0.4 grams. Okay, so if I divide 9 degrees by 1.2, then multiplied by, actually let's do it the other way around, that would be better. It's the same thing, but just, so I'm going to divide 0.4. 1 second. Let me do it the original way. That way it's easier. So let me start over. So if I divide 9 degrees, the temperature change, by 1.2, then I would get the amount of temperature increase for 1 degrees and then multiplied by the temperature decrease for 1 gram and then multiplied by 0.4 grams. I should get, doesn't matter whichever way I do it, 9 times 0.4 or 0.4 times 9, still get 3 degrees. What is the name given to the reaction which causes the temperature to increase? This would be exothermic. Now this topic is actually on energy changes, not chemical changes. The student repeated the experiment with 1.2 grams of copper and 50 centimeter cube of zinc sulfate solution. The temperature did not increase. Why did it not increase? That's because there was no reaction, or copper did not react with zinc sulfate. Copper did not react with zinc sulfate. The main reason for that is copper is less reactive than the zinc, so it cannot displace the zinc from zinc sulfate. Structure and bonding. Question number 3 is on the topic of bonding, structure, the properties of matter. Structure and bonding is used to explain properties of compounds. Metal atoms react with non-metal atoms to form ions. What group of elements does not form ions? The noble gases don't form ions. The alkali metals form positive ions because they lose electrons. The halogens form negative ions because they gain electrons. Potassium reacts with chlorine to produce potassium chloride. Figure 6 shows what happens to the electrons in the outer shells when a potassium atom reacts with a chlorine atom. The dots and crosses represent electrons. So you can see this electron of potassium is being lost. There's no electrons in potassium, giving it a positive charge. There's 2, 4, 6, 7 electrons in chlorine. That electron from potassium has been transferred to chlorine, as you can see here, giving it a negative charge. Describe what happens when potassium atom reacts with a chlorine atom to produce potassium chloride. Answer in terms of electrons. So, potassium loses 1 electron, while chlorine gains 1 electron. And that would actually be 2 marks, that sentence. Okay. Potassium forms K plus ion. Chlorine forms Cl minus ion, or you can call it the chloride ion. Potassium, it will still be potassium ion. Right? Right. And actually, this will give you 3 marks. Potassium loses an electron is 1 mark. Chlorine gains an electron is another mark. Reference to 1 electron is your 3rd mark. And any of these 2 points is giving you the 4th mark. But let me just make this a bit clear. Right? Both gain a full outer shell. The K plus and Cl minus ions attract electrostatically to form potassium chloride. Now, this bit you don't really need to write, but that's just for continuation and for clarity. In solid ionic compounds, oppositely charged ions attract to form a giant structure. Which structure represents the arrangement of ions in solid potassium chloride? So the chloride should be the Cl minus, and potassium is the plus. Each negative ion should be surrounded by a positive ion, or the other way around. So it's this one. So you got potassium surrounded by chlorine on all sides. Non-metal atoms share electrons to form covalent bonds. Water, H2O, is a covalent molecule. Table 2 shows the number of electrons in the outer shells of hydrogen atoms and of oxygen atoms. Hydrogen has 1, oxygen has 6. Figure 7 shows part of a dot and cross diagram for a molecule of water. Complete the dot and cross diagram. You should only show electrons in the outer shell. So, if you look in the periodic table, oxygen is in group 6, which means it has 6 electrons in the outer shell. It actually has 8 electrons totally, but it has 6 electrons in the second shell. So if it's sharing 1 electron with this hydrogen, it should do the same on this side. So if it's sharing only 2 electrons, the other 4 electrons are not being shared. So we draw it on the outside. Silica has a giant covalent structure. Figure 8 represents the structure of silica. Determine the ratio of silicon atoms to oxygen atoms. The oxygen is smaller ones. Okay, silicon, that's 1, 2, 3, 4, 5, 6. That's times 6. Oxygen, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's 12. So silicon is to oxygen, that's 6 is to 12. Simplify that, it will be 1 is to 2. 1 is to 2. Polymers have very large molecules. Figure 9 represents the part of the structure of a polymer. So you got polymer molecule 1 and 2. What holds polymer molecules 1 and 2 together in a polymer? It's not the covalent bonds. These are the covalent bonds. The question is asking what holds these two bonds. So there must be something attracting these two together. That would be weak intermolecular forces. Figure 10 shows the melting point of a polymer as the length of the polymer molecule increases. So it increases and then it becomes stable. Describe the trend. So if I label that as the first part and the second part, right? First part, what's happening at the first part? The melting point increases as the length of the polymer molecule increases. But it's not always increasing. So we need to describe the second part. Then we can't use any values as well. There's no numbers here. So we could say then the melting point levels off as the polymer molecule length increases. Copper bromide solution is electrolyzed using inert electrodes. Figure 11 shows the apparatus. So you have a beaker with the positive and negative electrodes with the copper bromide solution and a metal wire connecting the electrodes to the power supply. Which particle carries the electrical charge through the metal wire? Through the metal wire, it will be electrons. That's the only thing that can flow through metal wires. There are 4 ions in copper bromide solution. So you have the copper ion, the bromide ion, the H plus ion, and the OH minus ion. 2 of these ions are formed when a water molecule breaks down. That's the H2O, H plus and the OH minus ion. The symbol equation when a water molecule breaks down is H2O gives you H plus and OH minus ion. Complete the word equation. right? So you can't simply say hydrogen, and you could say hydrogen ion, right? What is breaking down to hydrogen ion? What do you call the OH ion? It is a hydroxide ion. Copper ions and bromide ions carry the electrical charge through the solution. The formula for a copper ion is Cu2 plus. The formula for a bromide ion is Br minus. What is the formula for copper bromide? So if copper has two positive charges, bromine has just one negative charge, you will need another bromine ion to cancel the entire thing. So for it to form copper bromide. So copper bromide is CuBr2. It doesn't go on the top, it goes here. Remember that. So it has to be that. Third option. Explain why copper ions move to the negative electrode. Well, they are oppositely charged. So which and electrostatic charges. Right, let me restart that again. So copper ions, Cu2 plus ions, are positively charged. So they are attracted to the negative ions, not ions, electrode. Complete the sentence. At the negative electrode, copper metal is produced when the copper ions are not decomposed. You could say discharged, yes. What happens to the mass of the negative electrode during electrolysis? Now, mass of the electrode, if the copper is being, the previous question is, it's the negative electrode, you got the copper ions being discharged, which means the copper atoms are going to stick to it. So what happens to the mass of the negative electrode? It increases as the copper gets stuck more and more. There are 4 ions in copper bromide solution. It was repeated again. What is produced at the positive electrode when copper bromide solution is electrolyzed? Now on the other side, it has to be to do with the Br minus ion. The bromine loses the electron to form bromine atom, but they'll join together to form bromine gas. But here they're just simply saying it's just bromine. This question is about electrolysis. Now, sorry, extraction of metals. Question number 5 is a higher tier question, which appears as question number 1. Sorry, getting ahead of myself. Question number 5. I thought question number 5 appears in the higher paper, but it doesn't. This question is about extraction of metals. Aluminium is extracted from a molten mixture of aluminium oxide and cryolite using electrolysis. Figure 12 shows the electrolysis cell. We have the diagram. Complete the sentence. The extraction of aluminium is expensive because the process uses large amounts of, you could say, energy, or you could say electricity. Oxygen is produced at the positive carbon electrodes. The oxygen reacts with the carbon electrodes. Which gas is produced when oxygen reacts with the positive carbon electrodes? So carbon plus oxygen will give you carbon dioxide. So carbon dioxide. Titanium is extracted from titanium chloride by reacting titanium chloride with sodium. The reaction between titanium chloride and sodium is carried out in an inert atmosphere. Suggest why the reaction is carried out in an inert atmosphere, meaning that there is no oxygen or any gases that will react with this. Sodium is a reactive metal. You're trying to displace the titanium by getting sodium to pull away the chlorine from titanium. If oxygen was there or even water vapor, sodium will actually react with the oxygen to form sodium oxide or sodium hydroxide. So you could say sodium would react with the oxygen to form sodium oxide. Or you could say sodium is highly reactive as well. Complete the sentence. The gas used for the inert atmosphere would be argon, which is the group 8 or group 0 gas. Hydrogen is in group 1, chlorine is in group 7. Both of them will not work. Balance the equation. So you're trying to balance the number of sodium and chlorine. There's 4 sodium here, so you would add just simply 4. Chlorine will simply be, it's already 4 here, 4 times Cl. Copper is extracted from copper oxide by reacting copper oxide with carbon. Figure 13 shows the apparatus. So you have a crucible containing a mixture of copper oxide and carbon, and you're heating it. The equation for the reaction is 2CuO plus carbon gives you 2 copper and carbon dioxide gas. In an experiment, 15.59 grams of copper oxide was reacted with 1.2 gram carbon. 12.7 grams of copper oxide was produced. Calculate the mass of carbon dioxide. So which means you're reacting 15.9 plus 1.2. This should add up to the total 12.7 plus X, let's say carbon dioxide. 15.9 plus 1.2, let's add them up. So I write it here. These are the reactants and these are the products. Let's do this on the side. Reactants mass is 15.9 plus 1.2. Add that up. Should have lined it up. It's okay. 1,167. 17.1 grams. So if I take away 17.1 minus 12.7 will give me 4.4 grams. 4 grams. Explain why the mass of the contents in the crucible changed during the experiment. Now, what happened to the mass of the crucible? It actually went from 17.1 to 12.4. So the mass decreased. Right? The mass decreased because carbon dioxide escaped into the atmosphere, into the air. What happens to the copper oxide in the reaction? Give one reason for your answer. Use the equation for the reaction. Copper, let's have a look at. Copper is actually losing this oxygen. So that means it is being reduced. Right? It is being reduced because the reason is copper oxide, CuO. Let's write it properly. CuO is loses the oxygen. Now that brings us to the end of this question number 5. Question number 6, as I said, is the higher tier question, which appears as question 1, and I will link it as a separate video as a playlist, which is on chemical changes about acids. It's a graph. Usually that should be a 6-mark question as well. There you go. Describe the method. Student want to investigate the volume of carbon dioxide produced with different mass of calcium carbonate react with hydrochloric acid, and there should be another question, which is 7. That's just one 6-mark question, so this should be a shorter question of 10 marks. That brings us to the end of the video. Thanks for watching, and I will see you in the next video.